All right, we have a new chapter, new unit here, starting with some exponent properties. We've used some exponents up to this point, but now we're going to dig in a little deeper. So if I have x to the n, well, that would be x multiplied by itself, dot, 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 n times. So like n factors of x. So for instance, 3 squared would be 3 times 3, which is 9. That one I think everybody knows. X to the fourth would be x times x times x times x. Now, if you had something like this where it was like xy to the third, well, then that would be xy times xy times xy. So whatever the base of that exponent is, including the parentheses, gives you the factor that gets repeated. So with this one, you got to watch out if there's like a negative in here. In this case, the exponent is only raising the base of the 2 to the third power. So you could think of this as like negative 2 times 2 times 2, because there's no parentheses including that negative. So that would be negative 8. Whereas if you have parentheses, then that negative gets included in each of those. And now that one happens to come out to still be a negative, but watch this. If it was like an even power, negative 2 to the fourth, well, that would be negative 2 times negative 2, right? 4 factors. Well, if you have an even number of negatives, that would end up being positive 16. Whereas if you had negative without the parentheses, it would just be negative 2 times 2 times 2 times 2, giving you negative 16. So you got to watch the parentheses on there. So let's get into some algebraic expressions. So for instance, if I had x to the n times x to the m, well, let's think of it for an example. If you had like x squared times x cubed. Well, x squared would be x times x, and then x cubed would be x times x times x. So you've got 2 factors, 3 factors, that's a total of x to the 5th. And so you could actually calculate that because you're just counting up how many factors there are. So that would be adding the exponents, x to the n plus m, right? There's 2 factors plus 3 more factors, a total of 5 factors. If I apply that here, x to the 10 plus 17, imagine you've got 10 factors of x, 17 more factors of x. That's going to be a total of x to the 27. This one's a little sneaky. Y to the 6th times y. Well, y to the 6th times y to the 1, right? That's only one more factor of that, so that would be y to the 7. And what if we were multiplying this? You might kind of think of this as being like 2 times negative 4 times x to the 4th times x times y cubed. So kind of just clustering the things that can be multiplied together. So 2 times negative 4 would be negative 8, and then x to the 5th, y to the 4th. So you're finding the total number of factors of the x and the y. All right, this would be pretty similar. I'm going to kind of skip that one. That's similar to the last one. This one's got a lot more going on with the extra like fractions and a lot more variables and stuff. So in this case, you would have 8/3 times negative 9/4 times negative 1/27. So multiplying the numbers. And then x squared times x cubed times x to the 4th. And then times y cubed times y to the 4th times y to the 5th. And one last part for the z's. Z times z squared. And notice the last factor doesn't have any z's in it. All right. I think we can actually simplify these fractions a little bit. 4 goes into 8 twice. 3 goes into 9 once. Oops, not once, 3 times. And actually here the 3 goes into 27 9 times. So that ends up being 2/9 after you multiply. And then x, well, you've got 2 factors, 3 factors, 4 factors. So 2 plus 3 plus 4, that would be 9 times y to the, well, 3 and 4 is 7. 7 and 5 would be 12 times z cubed. This would be similar for this one here. What if I had division? Instead of multiplying them, think about it like this. If I had like x to the 5th over x cubed, well, that would be 5 factors of x over 3 factors of x. And look at that, the x over x, those would cancel. Those would cancel. Those pairs are canceling, but you're left with x squared. So you could kind of think of this, you're actually dividing out 3 of those factors. In other words, you're decreasing that exponent. So you could find that by subtracting. So our property for the division would be x to the m minus n, because you're canceling, you're decreasing the number of those factors. So x to the 5th over x to the 9th, 9 would cancel out with 9 of the 25, so that would be x to the 16 when you do the division. All right, next slide. Okay, a little more going on here. Just got to do the division of the numbers. 104 divided by -4. Well, I do know that's going to be a negative number. What would that be? I'm grabbing a calculator. 104 divided by 4, 26. And then x to the, can you guess it? It's x to the 7 over x, so 1 is canceling out, so 6 left over. The y's would have 12 being reduced by 7 of those, so that would be y to the 5th. All right, so this one I think we need to do in 2 phases. The 3 times -4 would be -12. And then the x times x to the 5th would be x to the 6th. Y to the 10th, when you add those exponents, over 24, x to the 4th, y to the 4th. All right. And then we can now simplify. So that would be, well, let's see, the 12 goes into 24 twice. Looks like the x's would simplify, the y's would simplify, but I do have a fraction left over because I'm going to have a 2 left in the denominator, and then x squared y to the 6th. So I'm subtracting the exponents here because I'm reducing the number of factors after they cancel out. All right, now one more scenario for this section would be like, what if I raise a power to a power? Well, if I cube something, right, because that's x squared cubed. So I would have 3 factors repeated of x squared. And so in that case, I would add 2 plus 2 plus 2 to give us x to the 6th. But you might also realize, oh, wait, that's just 3 groups of 2. 3 groups of 2. So like 2 times 3, that would multiply those exponents. So in the case of raising a power to a power, it would be x to the n times m. So you can multiply because it's repeated groups of that power. All right. 2 examples here to finish up. Let's see. We got 5 times -9, -45. And I'm going to kind of hold off on that last one for a moment because I want to do that kind of in a separate step. But I'll multiply these first 2 sets of parentheses. So x times x to the 10th would be x to the 11th. Y times y to the 4th times y to the 12th would be y to the 16th, because I'm increasing the number of those powers. And then that last one here, that x to the 5th cubed, that's that power to a power. So you would have 3 groups of x to the 5th. In other words, that would be x to the 15th, because it's 3 groups of 5. Now we can finish this. -45, x to the, what do we do with the exponents for the x factors? I'm increasing the number of factors. 11 plus 15, 26. And then y to the 16th. All right, one last one. I'm gonna need a little space, I'll scroll up. Let's do the powers to a power first and just kind of leave everything else alone for the moment. So 36, x to the 7th, y to the 6th. But then the power to a power, that's 8 groups of y to the 7th. So that would be y to the, what do you think? 8 groups of 7, 56, right? Multiply a power to a power, you multiply the exponents. And on bottom, you'd have 9, x to the, well, that would be 3 groups of 2. So multiply, 3 times 2 is 6. And then y to the 5th. And let's see, a little bit more to do. I think I can combine those y's up top. So 36, x to the 7th, y to the 62 over 9, x to the 6th, y to the 5th. And then finally can start to reduce. That would be 4. And then what happens with the fraction? That would be x to the 7th, but x to the 6th is canceling out 6 of those factors. So 7 minus 6 would be 1. So x to the first power would just be itself. And then y, you would subtract 5 of those factors. So that would be y to the 57. And there you have it.